let's move on to the next slide. So the question reads, the following are similarities between all monomers of both lipids and proteins. So we have here the monomer of a protein, the amino acid, the general structure of amino acid, and then we have here general structures of lipids. So we have an option A and option B that both have hydroxyl groups. So is that true though? We have glycerol here in lipids, right? It does have an OH group, and glycerol is the backbone that forms fats and oils. But do we have any hydroxyl groups for amino acids? For the general structure of an amino acid? We don't. So we can straight out, we already can discard option A and B. What about option C, the nonpolar chain, and they both can undergo dehydration synthesis? So the second part of the statement, the dehydration synthesis, that's correct for both of them, right? Both of them can undergo dehydration synthesis to form like the chain, right? But what about the nonpolar chain? Well, we do have a nonpolar chain for lipids, right? Right here, right here, right here. But for amino acids, this R group can be nonpolar, but it can also be polar. So this nonpolar chain statement does not apply for amino acids. So this is incorrect. So we can already discard option E, right? But what about option D, the carboxyl group? So do both have carboxyl group? Yeah, there's one right here for lipids. There's another one right here for amino acids. And they both can undergo dehydration synthesis, which is correct. They both can undergo dehydration synthesis, as seen here. So the correct option will be D. The following question is, which of the following can be considered a monosaccharide? So I give you a whole bunch of options right here. And if you remember, the formula for a monosaccharide is CH2O, and then between parentheses will be an N, where N equals the number of carbon atoms. It must be greater than or equal to 3. So remember that the ratio within a monosaccharide, it has to have a molecule of water or multiple molecules of water. So if we have option A, right, C7H15O7, so we have 7, which is our N. So if we multiply N by 2, it should give us 14, not 15. And of course, oxygen should be the same number of oxygens as it is for carbon. So we can already say that A is not correct. What about option B? We have 6 carbons, which is our N. If we multiply our N by 2, meaning in this case, if we multiply 6 by 2, that will be 12, not 16. So that this is incorrect as well. What about C? N in this case for C is 8. If we multiply 8 times 2, we should have how many hydrogens? 16, right? And over here we have 17. The number, again, the number of oxygens should be the same as for carbons, but in this case, the number of hydrogens is not twice the number of carbons, so this is incorrect as well. What about option D? So now we do have, again, as in option A, we have 7 carbons. We do have 7 oxygens, which we're okay so far. And what about hydrogens? If we multiply N, which is 7, times 2, that will give us 14, right? So which of the following can be considered a monosaccharide? That will be option D. Okay, remember this formula, and you should be okay. Then we have this question. Dr. Hugo Strange is once again experimenting with humans. He is attempting to cause a mutation in his victims blank so they can code for a different blank. So if you remember our case study of the little kid that couldn't stop eating, we were looking at the gene sequence first. And if you answered this question in your handout that I gave you, We were looking first at what? Nucleotides, which were giving the instructions to do specific what? Protein sequences, right? And proteins are made of amino acids. So we started with the nucleotide, and then we looked at each of the amino acids that the nucleotides were creating. So the answer will be what? Nucleotides and amino acids. And if you remember the case study, you could have figured that out, because we first looked at the sequence of a gene sequence, which we were talking about nucleotides, and then we're looking at each of the amino acids that those nucleotides were coding for, in which those nucleotides make protein sequences. So the correct option would be what? C. And then we have this question, lard, which is manteca de puerco, I believe. Lard is high on saturated fatty acids, thus it will most likely be. Okay, so our great hint right here is that it's saturated fatty acids. So saturated means that what? Do you have single or double bonds? Of course, if it's saturated with hydrogen atoms, it means that it's all single bonds. Okay, so we can already delete option A and option B, because double bonds will be unsaturated. Saturated will be single bonds. So the only option that has single bonds will be C. But we have single bonds, right? So imagine that you're stacking together, we are packing a whole bunch of single bonds, right? A whole bunch of saturated fatty acids. That will make it very solid, right? Because you're aligning all of those single bonds. It will not be liquid. It will not have any fluidity. It should be solid. And if you also remember lard, manteca, right? It is solid. So the option will be what? D, none of the above. Because lard, if it's high on saturated fatty acids, then it should be solid because of the single bonds. So the correct option will be D. Now, we're going to go over isomers, right? As I promised you, we have to cover positional and chain isomers, which are the easiest ones that